No, you don't. Why is it important?
Why is so big?
Yes. At time 0, no one knows the Actually, technically, at time 0, one person would have to know the rumor. Yeah.
Time 0 is 10%.
So, but we don't know what percent. Ah, that's true. So, someone tell me a method they used to solve this. Will!
Yes, Miss Price.
So, tell me how you found an answer and what answer you got.
You take the derivative of dy dt.
And what did you
And
get?
you set it equal to 0 to find the max. And that means that y equals 1/2.
Did everyone get a half?
Yes.
So that means half the population, or 50% of the population, had heard the rumor at the time when it was spreading the fastest. There are other ways to do this, but that's a perfectly good way. Yes? That was so beautiful. Yes, that is an excellent other way. So let me tell you what I did, and then I'm going to show you 2 other ways, okay? So when I did this, I thought, all right, so we have this rate. I went ahead and distributed and said it was 2y minus 2y squared. Now, I found the derivative fully remember d squared y dt squared. Since we were differentiating with respect to t, right, the derivative of 2y is not just 2, it's 2 dy dt, right, minus 4y dy dt, and then I plugged in my dy dt's, right, and solved. And then I got my 3 points, which are actually the end points and then the critical number, and tested and found that y equals 1/2 did produce the max. I will tell you, so what's interesting about this is, did you guys differentiate with respect to time? It's okay if you say, it's okay to say no. Yeah, so what's interesting about this is if you differentiate just with respect to y,
Now you gotta say yes.
More special.
So think of this, instead of dy dt, think of this as like y prime, and then like y double prime would be 2 minus 4y, and you set that equal to 0, and you still get y equals 1/2. So I'm not sure, I'm not totally sold that this is appropriate mathematics, but it works. So, anyway, it still works. It still gives you that max value. But the other way that Claire said is to think of the graph. If you have a graph of a logistic equation, right, then the rate at which the population is, the rate is growing the fastest is here at the point of inflection. Because the rate of change, even though it's still growing, right, the rate of change is growing faster, 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 and then it starts to slow down. Does that make sense?
Yeah.
So that point of inflection, if you found the point of inflection, you also solved it that way. Right? So, a couple different ways. Oops. A couple different ways. So, either way, if you got y equals 1/2, well done. So now, what I want you to do is, at time 0, 10% of the people have heard the rumor, find y as a function of t. See if you convert this. You're going to have to map this to your traditional differential equation, logistic differential equation, right? And then convert it to the actual population equation, right? Your y function. What's L? 1. Does it make sense that your limiting factor is 1? Why?
100% of the time.
Will have heard the rumor. Yeah, because then 100% of the population will have heard the rumor, right? Okay, so your L is 1. So I want everyone to take a second and solve for y. Right? So solve for B and K. Oh, so you can't assume at times 0, 0 people, because it says over there at times 0, 10%.
Trey, stop. He's trying to say that if the rumor can spread to another population.
So it totally could. Yeah, it could. I mean, like Facebook. That it's a.
Well, we're just talking about this topic.
So then it could be over.
Then it's still.
But they're still part of the population.
Yeah, but
We're just talking about this community though, so it's.
It's just like a.
It's community.
Right.
Yeah. They are Amish morning.
What to do next to start?
Yeah, but also
Okay,
still go
so
out.
remember, you have two models that you've learned today. So this problem we have dy dt equals 2y times 1 minus y, right? So as a model, we learned dy dt equals ky times 1 minus y over L, right? So from here, we can figure out k and L. We already said L was 1. What's k? 2. Now, we've got our other model. This is the rate of change of the spread of the rumor, right? And this is the amount of the percent of the population that's heard the rumor, right? Would be the y. So now we need an equation that's just solved for y. What goes on top? 1. It's your L, right? What always goes here? 1 plus b. Oh, yeah, that's what we do. B is the negative 2t, right? And then you just have to solve for b. Yeah. So that's the key today, is being able to go from this to this. Remember, this is a no calculator question.
Were there calculators like we invented back then?
We used stones and chisels. Right? Rocks. Abacus.
Everybody else.
So is that why we can't use an abacus on our health test?
Although I learned the proper plural of octopus is not octopi, it's octopod.
It's octopus.
Trey's summer say 2017.
Reyes, I know it's 2016, but
Maybe 2017.
There's a chance it's 2018.
Alright, so anyway. Alright. So we have to move on. So we've got our original differential equation. You've got your k, you've got your L. You plug in the 1/10 and the 0, and you solve for b, and you get the b's now. Is that okay?
yeah.
Alright, I'm getting some thumbs up. Sorry.
McCoon.
Hey, so at what time t is the rumor spreading the fastest? Now part A said what proportion of the community had heard the rumor when it's spreading the fastest, right? So this is a y value. What are we solving for here? T value. So we've got our equation, we've got our function right here. Do we know the y to plug in? When the rumor is spreading the fastest?
Why not do the dy because you have the dy dt equals 2y times 1 minus y. Why can't
Is the rumor spreading the fastest when dy dt is 0?
No. It's when dy.
Oh,
It's when dy, the derivative of dy dt is 0.
But Ms. Price, wouldn't it also be acceptable if you just
Well, then
find the
that's
critical
not
value?
Is it just the point?
Yeah, you just look.
Oh, yeah.
Just the
Yeah, but you
denominator.
just have to find the t
Because
value.
it's really pretty easy to just plug a 1/2 in there and solve. It's not that
Nice,
crazy.
yeah.
But it's good that you're looking for other methods. I'm not discouraged.
We're good. Did you know the plural of squid is squad?
I Are you joking or?
No, it's I'm serious. They changed it.
They changed
They
it.
changed it.
Wasn't there a petition to have?
It was.
There was a petition to have the
Yeah.
plural
There's a petition to have
squad.
It's squad.
I like that.
Oh yeah, Miss Bryce, did you know that the official pronunciation potato is now potato? It is. Trust me.
Yeah, okay.
Trust me, Miss Bryce. Potato.
I am so recording third period from now on. So,
Please.
yeah. Alright, so what time is the rumor spreading the fastest? Well, you figured out the y value when the rumor was spreading the fastest in part A. Y was a half, so you're just plugging a half in for y and solving. Remember, this is free response, no calculator. Anything equivalent to correct is correct, as long as it's numeric, right? So this, the death of me says, this is fine, this is fine, this is fine, this is fine, they're all good. You did that in your bed? That's really impressive.
I know it is.
Yeah.
My parents say I'm
Alright. Don't look. Okay. Alright, so I want you to use the Kari-Saturnus method on this differential equation to find this limit. Take a moment. Don't be deceived by what you think might be L.
Ooh, you got to bypass 6 up there. Take that 6 out. So, right? I think 6 out.
Kari-Saturnus says that
So,
the derivative has to equal what when the limit approaches infinity? It has to equal 0.
300, boys.
yeah, 300. 300.
I wonder if Kari-Saturnus knows that her name is infamous now.
Search her out.
Yep.
Yeah, see where she is now. Look her up on Facebook.
Cole Dunbar, do it.
Eventually.
Look her on Facebook.
Cole Dunbar.
Might not be.
I'm not a stalker.
I'll use my trusty abacus to solve this problem.
If you look at this, you could be tricked into thinking L was 50,
Oh, it's not.
but it's not. Yeah.
Reyes, why are you
Because
Wait, what?
like
no abacus?
Yeah. So really, technically, guys, if you were to write this in using our model, remember that our model is dy dt equals ky times 1 minus y over L,
Oh, yeah.
right? So we don't have a 1 here, we have a 6 here, right? So what we have to do then is, yeah, pull out either divide by 6 and think of it like that. So really what you really get is 1/6 y times 1 minus y over 3. You don't have to do this. Kari-Saturnus just says, hey, set that equal to 0 and you get y equals 300, right? I'm just showing you that if you had to rewrite it.
She lives in California with Ian Sigsworth now.
She lives in Riverside.
Oh,
She
yes,
can
yes,
go
yes,
whenever
yes,
else.
She lives in California with Ian
Ah.
Sigsworth.
You gotta put it. Alright, that works.
Nah, man.
6.
She lives in Riverside, California with Ian Sigsworth. She moved to
Yes.
California.
Alright, please don't let there be another one.
Miss Price, you know what you can do? You can lock the door.
Oh, you're
Alright.
fine, yeah.
Now,
I want to wait.
oh good, we got lots of time. So I found out, two quick things that I want to talk to you guys about. First, your parents asked me, okay, your parents, not like any specific ones, but a number of parents talked to me about how they were worried that you weren't doing enough AP, you wouldn't have enough time to do enough AP exam practice prior to the AP exam. Because we finished all of our topics with only like 1 week to spare, right, before the actual test. So and plus, the other thing that I think concerned them was the fact that your last semester final was all AP problems, and we hadn't done any until like the week before the final, right?
Yeah.
So what I promised them, and I had already had this in the plan anyway, was that I would sprinkle AP practice throughout the semester, right? So we are going to do AP practice problems, whether they relate or not to the lesson, throughout the semester. We actually just did one, right? That was back from the 90s, but it still was a problem, right? So anyway, so now we're up in the 2000s. We're actually pretty darn recent. Some of you were in high school when this problem was done, right?
Oh,
Yeah.
wait, I might have taken this one.
Yeah.
Possibly.
Cocoon make it take
Cocoon, help us.
I took it 3 years ago, so yeah, this is mine.
This is yours. Okay, let's read through it. See if you remember. Do you remember this problem? Oh, fantastic. Okay.
Can you all give us a hint?
All right. Now, Mr. Thomas's students did this one to prepare last semester. Do you guys remember this one?
No. You
No?
did?
Oh, third period, like at least 6 people said that they did.
Apparently he would like switch around the problems he do though.
Okay. So anyway, here we go.
Yeah, he did occasionally he would.
On a certain,
Spice them up.
so that's good. We're just gonna walk through this without sitting there and doing all, but you're welcome to write. But I'm just gonna kind of we'll walk through this together a little bit. Just kind of strategize. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 9 equals 45 cosine t squared over 18, where t is measured in hours from 0 to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. First question, find G prime of 5 and interpret your answer in the context of the problem. This is a calculator question. So, first question I have for you is, does everyone in this room know how to find a numeric derivative on their calculator?
No.
No.
Yes.
No? Yes?
You do.
No? There's 2 ways to do it. So everyone should take a second just to try it. One way is to use the nderiv function, which is under the math menu. And one way is to just put the function into y equals, go to the calc menu and pick dy dx, and then type 5. So either way, you've got nderiv, which is under math. Yes, numerical derivative. Yep. And feel free to use x, you don't have to use t.
It's 8.
And then comma t.
Negative 5x sine negative t squared over 18.
Hey, Matt.
Do you want to check your answers?
But then also then we'll just go like boom, 2, you get the second derivative. I'm gonna get the derivative of a
Why were you?
You just plug in a, yeah, we
Wait,
don't
Miss
need
Price?
Wait,
Miss Price?
yeah, it's error syntax.
Okay, negative
Or just like a bunch of
24.58.
errors.
The College Board expects you to do 3 things on your calculator. Number 1 is numerical derivatives. So if you have a question and it's a calculator question and it's find the derivative, you are expected to just write G prime of 5 equals and just put the answer. Alright? You do not sit there and differentiate the function by hand. Alright? And you don't get extra points for doing that. As a matter of fact, they'll like say, wow, why aren't you just using your calculator? Alright, now, the next part was using correct units, interpret your answer in the context of the problem. This was G prime, right? So when you have G prime of 5, G prime is a rate, right? A rate of something. So don't get too bogged down and figure out how to word it. Think to yourself, G prime of 5, or whatever you got for G prime of 5, is the rate of change of, so you can literally just write the words, the rate of change of and then write whatever G is. And so it's the rate at which unprocessed gravel arrives at a gravel processing plant. Make sure now you use the new units. The units for G prime, remember G is tons per hour, what would be the units for G prime?
Tons per hour.
Yes, tons per hour or tons per hour squared, right? Make sure you also mention T. When you are describing your answer, you not only describe output with units, you also always describe input with units, right? So you would make sure that you say at T equals 5 or 5 hours, right? The rate of change in tons per hour squared of the rate at which unprocessed gravel arrives in the plant is whatever you got. So you don't have to put like the rate is decreasing by whatever. Don't worry about the negative decreasing kind of a thing. Just put changing and put what you got, right? So as a matter of fact, you're better off just putting changing than putting decreasing. All right. So this is the rate of change that the unprocessed gravel arrives. What if we wanted the total amount of unprocessed gravel?
Integral.
Yes. So we do a definite integral, right? So if we have a function for the rate of change, then if we want the total amount, we do the definite integral, right? Is everyone okay with that? You fairly comfortable with that concept? Yes.
Wait, well, I just have a question, like how to get so I can get like a indefinite derivative, but I can't like then do I just have to manually plug it in?
Oh,
Does
no.
that make sense?
Oh, okay,
89.
on an 89.
Yeah.
Okay, I'm going to show you something that you're going to get a kick out of.
Good. I'm
All
excited.
right. Yes, as you should.
Give
All right,
my face
so
some videos.
say y equals x, right?
Yeah.
We got it. Look at that.
So if on
Camera skill right there.
89, you do the derivative of x cubed comma x comma 2,
Then it gives
right?
you the second derivative.
It's going to give you the second derivative, not the derivative at 2.
Yeah.
So if you do comma 3, it'll give you the third derivative, right? And so forth. So what you do instead, if you want to plug a value in, is when you type this in, you just do vertical bar x equals
How do you do vertical?
whatever, 5, 3, whatever number you want to plug in. Vertical bar is on there, it's like on the left-hand
Yeah,
side.
I guess underneath equals.
Remember in math, vertical bar means evaluate? Yeah, yeah,
Hold on, Mark.
yeah. So you can do
2017.
that for anything.
I didn't know
Anything. As a matter of fact, just so you know, Cole, when I have a function and I have to plug a bunch of numbers in and they're random, if I'm not on the graph, if I'm on the graph window, you just do trace, right? You sit there and hit the numbers.
Yeah.
But if you're on the main window on an 89, then what I'll do is just type my function with a vertical bar x equals, and then you know that you just sit there and type in
Yeah.
all the numbers you need.
Sweet, thank you.
Yep.
Gracias por su ayuda.
Alright.
That's
Good.
cool.
So the next one, is the amount of unprocessed gravel increasing or decreasing at time t equals 5? So I know that an amount is increasing when what? When the derivative is positive, right? And decreasing when the derivative is negative. So we need the rate of change of unprocessed gravel. This is the total amount of unprocessed gravel. So remember that the unprocessed gravel is coming in at a rate of g of t and going out at a rate of 100, right? So if g of t is bigger than 100, then the pile's getting bigger. If g of t is less than 100, then the pile is decreasing because it's coming in slower than it's going out. Does that make sense? So really what you're doing is comparing g of 5 to 100 and saying, is g of 5 greater than 100 or less than 100? Because that's your rate of change of your amount of gravel. The rate going in minus the rate coming out. That pretty much goes for all of those rate problems, because all of these have a rate coming in and a rate coming out. So your general rate of change is just the rate that comes in minus the rate that comes out. Okay. And then the last part, what is the maximum amount of unprocessed gravel during these hours? This is a maximum question. Is it a maximum question on an open interval or a closed interval? Closed interval. So what do we do?
That's the end point.
we find the derivative, we find the critical numbers, and then we test the endpoints and critical values, right?
This is the calculator problem. Can we just do n derive? Wait, no, not n derive. N integral.
N integral.
Wait, I mean f n integral.
Because it's like on this one.
Yes, but you need to know what
on this
you're taking the integral
So it
of,
defines.
right?
Yeah.
Okay, so here's the thing. We want the actual maximum amount of gravel, right? So your amount of gravel at any time t, we started with 500, and then we take the total amount of gravel that's come in minus the total amount of gravel that's gone out, right? That's your amount of gravel at any time t. So,
Wouldn't it be?
oh, t, sorry, I'm writing 8, it should be a t. Yeah. So anyway, so your amount would be 500 plus the total amount that's come in minus the total amount that's come out, and then you'd have to plug those t values in, right? So t of 0 you know is 500. So you'd have to plug in a t of 8 and then a t of whatever you get. Okay, so for this one, oh, look at that. Hey, there's your amount. They used S, but that's okay. So your amount of gravel, 500 plus integral of 0 to t of g of s minus 100. There's your amount function. You set your rate of change equal to 0, you get your critical number, and then there's their little test written out really nicely. So 0, critical number 8, bam, bam, bam. Highest value is 635.376 tons.
Wait, how do you know exactly if it's an open or closed interval again?
Oh, just how it's presented. This one was presented with a closed interval 0 to 8.
Oh, okay.
Squad.
Good. Any other questions? All right, we'll do more where you like really work through them, but yeah. So, oh, I have it's warm up time on this because this was originally your warm up, and then I changed it.